Hello, everyone. Welcome back at Let's Talk About Data Show with me, Lydia Ray. My day job, I'm Senior Analytics Solution Architect at AWS, but also I am one of the hosts for Let's Talk About Data Show alongside lovely chaps, Ibrahim, Prasad, and Tony as well. Ibrahim is on the chat support. We'll help you with any question that you have. Pop in the chat. He will help you to find some information for you. So I'm based in the UK. For those who doesn't know, I'm based in the UK in Liverpool, up north, not so far from Kate, to be honest. At the moment, it's sunny, but sometimes it's cloudy. I can't really tell, but it's still a nice weather so far this week. And let me know if you tune in from wherever you are. Say hello in the chat. Tell me where you tune in from, which country, which city, how is the weather like, and so on. For those of you new for this show, this is a Let's Talk About Data show. We talk anything about data from data analytics, AI, ML, anything that related to data. We show every Monday, 4 to 5 p.m. British summertime. And we have community page that Ibrahim can share in the chat for you to see all the past show that we did, all the conversation that we did. And if you have specific topic, I'll highly encourage other DM one of us in like LinkedIn or put it in like comments in the community page. Tell us like what topic do you want to listen and so on. All right, I'm gonna stop talking a little bit. I have a guest here, which is a good friend of mine. We used to work together back in the days, and it's just nice meeting like friends to be in the show is always nice because it's bring back all like after work chatting because at work after work our geeky folks always talk about tech stuff, always talk about data stuff.
You're
So
not making us sound very cool, Lydia.
exactly. So I will let you introduce yourself, Kate.
Thank you. So my name is Kate Gavron. As Lydia wonderfully said, I used to work alongside her, AWS. I was a database solutions architect. So as you're going to be discovering probably a lot through this talk, data analytics pretty much go hand in hand. You tend to not have one without the other. So I do all the really boring stuff, just building up tables, and Lydia would do all the fun stuff. So we used to work together quite a lot, and it was some fun. So hopefully today we're going to spend some time talking about some of the things that we learned, some of our experiences, really how to choose. There's so many different systems now out there. So thank you for having me again, Lydia.
No worries. She is very humble. She's not just a like solution architect, but she also like an author, published author, wrote a couple of books. Um, Share a little bit more, Kate.
Don't write a book, I think would be my recommendation. I've written two. The first one, I wrote a book on the database specialty certification, which then AWS pulled about 6 months after my book was released. So that slightly helped my book sales. And then the second one, I wrote with another AWS colleague. We wrote a exam guide on the Solutions Architect Associate exam, and that was published about 4 months ago. And both thank you, Ibrahim. Oh, look at you doing my PR for me. Yeah, so both available on Amazon. So feel free. If you buy them, you get me a coffee, effectively.
So Ibrahim shared this is the link that I share at the moment is for the database certifications, but also like I heard from a lot of people, this is not just for you to get certification, but you get the knowledge around like what database services around AWS as well. And the other link is for this is community, AWS community. Let's talk about data shows. And okay, Ibrahim shared another link, which is this one is for the latest one 4 months ago being released or launch certification for Solution Architect Associate. Please do check out. Let's see. Is Ibrahim is one of the hosts. Say hello. Let's see who is like Erie underscore edits. Hello. Darip. I hope I pronounced it correctly. Hello from Charlotte, North Carolina. Hello, good morning. Watching from somebody watching from Los Angeles. Hello, good morning as well.
Nice location.
Everyone, if you're new or if you're used to the show, please say hello and pop in any question that you have, also where you are. Okay, let's get to the topic. The first thing first when we start about this, like in the past, like if you're talking about database, if we're talking about column and rows, that's it. That's the only database. But last couple of years, when you're talking about database, the question continues. And I'm gonna. What is your experience, Kate, when you speak to customers, and then when they say like, "Hey, when your databases, our database problems," what is the conversation starter there
Sure.
that you got?
Two things, nearly always. Performance. Normally, it was running okay. Now it's not. What's happened? We promise nothing has changed. Is a fairly common one. Something that always has changed. And the second one is cost. So again,
Okay.
we're seeing our costs, or we've had to increase our instance size, or we're using serverless, and we're suddenly burning loads more ACUs, for example, Aurora capacity units. So effectively so basically burning like more money trying to run the same system that they did before. So I think they're like the main ones that we tend to get. I've had one customer, I think one in history that I can remember, who actually hit size limits. And given that the size limits now, I think they just went up as well, didn't they? They were 128 terabytes, and now they're, I think, 256. I mean, it's huge. So they hit 128 terabytes, and it's not normally storage that's the problem.
Yeah, it's just like run through like what AWS has in the like database portfolio. We have DynamoDB, we have RDS, and also Aurora in terms of relational databases. We have Amazon Neptune for graph databases. Of course, for analytics, for OLAP engine, you have Amazon Redshift, Amazon OpenSearch for log analytics, indexing or search use case, and what else, Amilis?
DocumentDB.
DocumentDB, yes, and then we have TimeStream as well for time series data. There's so many databases that now we have purposely built for a specific use case. It means like you get the best price performance. Okay, so if let me check in the chat. There's like greetings from good morning from Peru. Okay, hello. Let's do it. Yes, let's do it.
It's a good company. It's a good company name.
Yeah. And then greetings for Argentina. Hello.
Oh.
Okay. I'm gonna ask the first question. Like, if I am somebody like who is new, let's say I have relational databases. There is either like price, or performance not good, or concurrency not good. Like, what is the first thing? Like, if I want to choose a database, what is the first thing that I have to ask myself? Or I have to like find out.
Okay. I'm going to say something strange, given that my job is databases. And my honest first question is, do you need a database? Now, everyone's probably be going, what? Of course you do need a database, but you don't always. And there are other options now that exist. For example, you can put data in S3, and there's been so many new things coming out. S3 tables, you've got iceberg compatibility in there now, so you can effectively build a data lake, which gives you different access. Well, that isn't a database. It's a data store, but it isn't a database.
Okay.
And actually, for many use cases, S3 will be quicker, cheaper. So that's always my first question. When someone comes to me saying, hey, we're designing a new system, what database do you think we should go for? I will always ask, do you actually need a database? So that's the first one. Assuming that you do, that you've gone through and gone, yes, we definitely do need a database. Then you need to start looking at, I always say, start with your application. So to me, a database, its tool is just to serve data to your users. What that database is only matters as far as you can operationally support it. So I'll come back to that. But ultimately, everything should be designed for your end users. So as long as the users are getting the information that they need, then it kind of doesn't matter what the database engine is, as long as it fits the needs. So what I mean by that is you need to start looking from an application point of view. So if you go back in time to when I think Oracle was kind of running the world back before things moved on. So back then, the Oracle database was designed, and you would do a thing called normalized form. Anyone who's done a computer science degree will probably remember that. You pretty much start with a piece of paper with all the boxes on it, your address in one, and an order form with items, and you split them all. Everybody knows it. You split them all into tables, individual parts, and you draw this wonderful data-like map of how everything fits together. And the reason that was done was because of storage. So 30 years ago, the most expensive part of any database system when Oracle first came out was the storage. The disks were the most expensive part of your system. We don't live in that world anymore. So now the most expensive part of any system is the compute. So effectively
The
your
query
CPU and your
engine when you're
memory.
running.
Yeah, exactly. The query cost now is very high, and actually the storage cost is very cheap. So the old way of doing things, of normalized form and having lots of individual tables, they were designed to be low storage. So you didn't have duplication, you minimized duplication to make storage cheap. But that meant that your queries were expensive because the queries now had to go across to all these different tables and join. That didn't matter when we're talking about what, a megabyte of memory, maybe, of that. It didn't matter. Like, these were very small queries. The world has changed, and I now talk to people to get away from normalized form. And this idea starts with, once you ditch normalized form, and once you kind of get over the idea that actually you don't need everything to be linked, you don't need a one-to-many relationship, you don't need link tables that allow you to do the one-to-many joins, suddenly it all becomes a bit freer. And then, so do you actually really need that structure anymore, given that storage no longer is the blocker? So if you just duplicated data all over the place and had other mechanisms to keep that consistent, would that work better? And the answer for most customers is yes. And the blocker, or what's stopping most people move away from relational, given this is my background, I used to be an Oracle DBA, so I've gone through this pain, is I guess a bit of, we've always done it this way, we know it, so we'll keep on doing it. And I think when you actually start to look at your use case, so the best way I would start to answer the question more directly was like, I would go and ask, what is your application doing? What are the use cases? Have a look at the specific code, the modules. What is it actually doing? What queries is it actually running? What are the actual sort of access data patterns, we call them? How is it being updated? What are the queries? And then start to look at that and understand what type of data you're working with. And that should open up then more options.
Okay, that makes sense. I know, like, moving back, like going back a conversation before, like you mentioned Amazon Simple Storage Service, Amazon S3 is a data lake, and that is not a database. So it's a data storage.
Yeah.
Can you, for those like who are not familiar with data lake and databases, like if we put it in a very simple terms, like what is the difference of databases and data lake or data storage?
I think the line,
database always column and row, or like where is the line?
No, because then you have graph databases. I mean, you could even argue that Dynamo had columns and rows. It sort of does. It's fluid. You could argue that then actually you've got graph databases which absolutely do not have column and rows. They have attributes and nodes and edges, and that's a whole world that I don't fully understand. But so I think the main difference is that S3 works off of files, whereas databases do tend to work off of rows and attributes. So there is that slight difference. So in S3 you would load files, even if you're running something like Iceberg or like Apache or like basically like things like Hoodie or S3 tables that kind of mimic a database. They're effectively like a layer over the top that makes your files queryable like a database. But ultimately that's file storage, whereas a database will be, its storage will be in different, in the, effectively in database specific binary storage formats.
Okay, that makes sense. Let me see in the chat. Like, there's a couple of people like put this comment in the chat. Schizophrenic web developer. I store data on a file on this. I use this as my database.
Yep.
Hey.
Yep. It works for you. It's probably this. I always say start with the simplest and only make it more complex when it doesn't meet your needs. So if that works for you, great.
Hello from Madrid. Hola. And then I think schizophrenic web developer refers to like the most expensive thing is memory. Yes. Oh yeah, memory is the most expensive thing. As RAM is most expensive, then the RAM is more expensive.
Yeah. All those words take me back to when I used to be a gamer before I had a child, and I'd spend all my money on really expensive DRAM modules for my gaming computer. Now I have to watch Peppa Pig instead.
And there's another comment like from schizophrenic. Do this with DynamoDB to duplicate everything. Yeah, that's correct. And hello from Tokyo. Hello.
Okay. I've got a lot of time zones covered today.
go back to the database topic. So, like when you talk about database, it's always like, although we have now like DynamoDB or DocumentDB or Graph databases, but we always talk about like SQL. And then usually we talk about the database, people say like, we want to query in SQL or something related to AC transactions. And where do you see this? Like when you decide database, is a SQL also and ACID transaction also the factor to decide whether which database I want to use, because not all
Yeah.
database use SQL nowadays.
I think again it goes back to understanding exactly what your application is doing
Yeah.
and what is the specific things. You would normally start to see certain areas depending on what you're trying to fix. So let's assume you're trying to fix a performance problem.
Okay.
You will probably start to see some pretty clear indicators in things like Aurora. So you might start to see that your numbers of connections have like gone up. That you've got like high connections coming in. You'll start to see like CPU and memory contention issues are basically like starting to show. And you'll just generally see that a lot of the queries, if you're using performance insights, which I recommend everybody enables, you'll start to see some of like the queries will be running slower than previously. And all of those areas, sometimes you can tune them, sometimes you can make some changes, but quite often you get to a point where no amount of tuning is going to help.
And then that is the time you
Yeah.
start thinking like, okay, maybe this is not the most appropriate database for my data storage.
Yeah.
And you have to go back to like, okay, what is data access pattern? What is exactly my use case to then map it back to like, okay, maybe it's DynamoDB, maybe it's DocumentDB, or maybe TimeStream, or maybe Graph SQL, and so on.
Yeah, I
Okay.
think that I think it'd be extremely uncommon to go from Relational to Neptune. I did have one project that did.
Okay.
I did have one project that did, and they agreed that they should have done it in the first place, but they were basically too afraid. If you heard what I was saying about everything else they had run on Postgres, so they kind of just went, okay, we need a new database, even though they knew it kind of fitted a use case for a graph database. They were so, but everything we have is Postgres, therefore we'll go with Postgres and we'll try to make it work, and it did. I mean, ultimately you can.
Yeah.
It's just a query. You can do graph-esque queries in Postgres. Effectively, you just do almost like a cyclical like query, but you end up with an awful lot of nested structure, and it's not optimized. And this is the point about you can do pretty much anything in pretty much any database, but it probably won't work very well.
Yeah.
And
So
I think
dialing in like that like Neptune and then Relational RDS or Aurora, like where is it to say like, okay, this is, you better start from scratch in Neptune or in like graph databases. Don't use Relational. Yes, you can, but like at some point you'll move to Neptune anyway because this is not going to scale or this is not going to fit for your use case. When is it like somebody get into the use case and say like, okay, let's just do like, okay, steep learning curve, but like it's safe a lot of time later on down the line.
Yeah, exactly. I think it comes down to, so any conversation where you're talking about connections. So, okay, you want, especially for things like graph. Graph is a fairly easy use case to understand it because it's actually quite easy to imagine. So when you picture what you think your data should come back as, are you picturing effectively a good old graph? Are you picturing bubbles showing Kate is friends with Lydia and Kate likes, I don't know, cake? Therefore, it's likely Lydia will like cake. Because if you kind of, if you're mapping those kind of connections where you want to see how things are linked together, then things like fraud detection, nearly all of the fraud detection databases that your bank use, most of those are built on graph databases now. They also now use AI to do extra power on the top as well, because they're looking for connections. So they're looking for what's normal for you and for people who are like you based on your modeling. So they will model all of your transactions, the locations that you go, how much do you normally spend in these different places. And as a result, they can very quickly start to see patterns in your data. And then they can see if suddenly, if all of your graphing is kind of around here, and then suddenly you've got a massive outlier on the other side with different connections, that's instantly going to trigger their bank alarm system to go, something's not right. It might be that you have just bought a new kitchen, and that's fine, but they will probably give you a call to double check.
Okay. There's one question asking about schizophrenic web developer asking about what about doing GIS, which database is good for this.
Okay, so GIS, I'm assuming you're talking about geographical information system.
Yeah.
So effectively, location mappings.
Yes.
Postgres probably quite good as a AWS one because you've got Postgres, which is an extension that you can plug,
GIS, yeah.
you can put on it. Again, it sounds weird, but actually, if you're depends what you're trying to map. If we're talking about distances between objects and connections, if you're talking about different like things like connections, then you could map this physically in graph, and you can have effectively a diagram showing locations in a graph database.
Okay.
I mean, this isn't something that I tend to use a great deal. So I think a lot of people I think it's a new one that's coming in, but I think the one, as I say, I know that Postgres has it because it just caused me a big problem with the customer doing an upgrade because like the spatial data like modules didn't upgrade well. So I know about that one. Oh, there you are. Look, Ibrahim's posting a doc. Oh, look, you see, you could have just read that entire website and then we didn't need this talk at all.
PostGIS.net.
Yeah.
Look at it. PostGIS.net is related for GIS data that you can use. Postgres. So if you use Postgres, I mean, you can have the option on AWS either like Aurora or RDS or DSQL, I assume, or DSQL also support that. I think there is one that is integrated GIS. Yes, this is PostGIS. I think that we talk about, and Ibrahim just posts like some roughly like prescriptive guidance how you to use databases, and then this talk will talk about like something from that, and then what is actually on day to day. As I assume like Kate like meet a lot of different customers that asking probably a similar question. We got the same performance issue, but then the answer will be Dynamo's performance issue, but the answer like yes, you can still use relational, but in the different way, right? Like Aurora or the SQL and so on.
Well, I think so. Just one thing I want to point out on this though is that a lot of this functionality also depends on where do you need the processing to take place. So let's say you do want to work with, like spatial data and mapping data. Ultimately, mapping data is just coordinates. It's just a set of numbers. There's nothing more, there is, but in theory, it's not that much more complicated than that. So if you start relying on a database to do the complicated parts, then you can end up a little bit stuck and not able to migrate. So let's say you put everything in Postgres and use Postgres to store this data because you use that from sort of its processing modules. You will probably find it quite difficult to change that. So if your needs change in the future, migrating away, it's a bit like when Oracle brought Java into the database and they tried to get everybody to do it. They did that for vendor lock-in. They did that to make it really hard for you to migrate your away. So whilst a lot of these plugins and extensions are great and they definitely add an awful lot of functionality, they definitely make it harder for you to change in future if the needs of your database are different. So I'm a massive advocate for a database should do database things and an application should do application things. A database stores data and returns it back to you when queried in the fastest possible manner. Okay. Do you need GIS in there, or could that part be pushed onto your application side? It depends, because if you put it on the application, you might have more latency because you might have to do more round trips back and forth rather than a stored procedure type running in the database. So everything's a trade-off, but I think that's just worth bearing in mind that the more code you put in your database, the harder it then becomes to ever migrate that away.
Is that you mean like things that you have to compute on the fly? I mean, ideally happen in the application code side. Well, database basically just push the data out. You shouldn't like calling store proc to like process on the fly to serve the data.
That's I think in my ideal world, I would not. To me, in an absolute ideal world, you wouldn't even have any stored procedures if possible. But that's impossible, because then that would mean that you'd have to constantly keep sending data back and forth to the app. So I get that point, but I think I quite often see too much code in a database, and a database's job shouldn't necessarily be very complicated code. Stored procedures tend not to be that complex, but when you start getting things like Java in your database and you start going really deep, I would we've gone slightly off topic, but I think when you start getting a lot of code, a lot of programming in a database, it just makes that, it can make it very hard. I used to work as a database migration specialist, and the hardest thing was migrating like code and stored procedures, Java, like procedures away from things like Oracle. Really, really, really difficult.
Okay. And in terms of other comments, Amazon Aurora and Amazon RDS with PostGIS extension are the primary database solutions. The integrated GIS system, yes, that's correct. Thank you, Mike P. Fung. Okay, and then talking about being resilient and scalable, and how, like, if anyone want to build more resilient database, well, we choose one databases, and then the use case might growing, like the company growing, the application growing, use case growing. Maybe it wasn't have the fraud detection before, now you have fraud detection, and you have to incorporate the graph databases now. Like, how do we tackle that basically? What do you see in the customer, how they being resilient and scalable? Looking into the future, there will be more type of databases coming in probably.
We see more customers moving into things like Dynamo. Dynamos would tend to be, if you're moving away from relational, if you get to the point where you're like, right, relational is no longer working for what we need, the most common one that people move to within AWS is Dynamo. And I think it's because Dynamo is very simple. It's also incredible that you can effectively scale. Like, the scale of Dynamo is absolutely insanity. You would never get anywhere near that. I mean, DSQL gets close. We will talk about DSQL. DSQL, I think, maybe potentially gets close, but I still think Dynamo would beat it in an outright fight. And I think because Dynamo is still like a table with columns and rows at its most fundamental, it's not that difficult to map it across. And there's lots and lots of resources that talk about how to move from a relational to Dynamo. There's this thing about like single table like design, which is effectively where, similar to what I said earlier about forget duplication, it doesn't matter. You just put kind of everything into a table, you duplicate everything. It doesn't really matter because the storage is very cheap. And effectively you look at your query access. So if you did like a select from, and you had 3 tables that joined, you'd effectively take that result set of the 3 tables being joined and put that entire result set into one table in Dynamo, if that makes some sort of sense. So you might end up with like lots of sort of like duplicated data. So you might have your order ID repeated 1,000 times if there were 1,000 items on that order. Whereas in a relational, you tend not to do that. You have one order ID that then maps to the order item. But on single table design on Dynamo, you'd have maybe thousands of order IDs with, an individual order item for each one. And there's lots of clever tricks you can do about using compound keys and lots of, I'm not going to go too deep into Dynamo design, but there's lots of clever ways in which you can fairly simply map relational data to Dynamo. I don't think there's many other databases, other like NoSQL databases, where you can do that quite so easily. You definitely can't go from relational to OpenSearch. Well, again, you'd have to completely remodel. Same as Neptune. Again, you can't map. You have to completely rethink everything about it. You have to rethink your entire methods of how you access the data. So I think that tends to be the most common patterns. People going from relational. Dynamo tends to be a first hop.
Okay, and it's common to like have both, like, okay, we have like a relational, either RDS or Aurora, and also Dynamo behind the scene, use both of the databases for different use cases, basically.
Yeah, again, I think the biggest blocker is around like operational ability to support this. It's something to support that, is that ultimately at the end of everything there are humans. And there are humans that work in operational support teams that have to try and maintain and fix and be on call at 3 a.m. And realistically, you can't be an expert in hundreds of different database types. It's just not possible. Like my role and yours, we have to kind of know all sorts of bits. But apart from, relational, that I probably, I don't know, when I say I'm an expert, probably not. I'm very good at relational, but the NoSQL side, I need to know it. But I don't know if I could support that at 4 a.m. You know what I mean? I don't know if my knowledge on things like DocDB or whatever are good enough to jump on a break fix call at 4 a.m. So And I've been doing this for 15 years. So that's the biggest blocker. So AWS had this idea, and still does, of like purpose-built databases where you go to use case and you identify the right database for each thing. Wonderful on paper. Absolutely great. I totally support it on paper. As a theory, fab. In reality, you'd have to be a very big company to have a big enough operational support team to have 11 different databases, plus Postgres, MySQL, Oracle, MariaDB. You've got 15, 16. It's not going to happen. Not going to happen. So that's the biggest blocker, actually, is people that you just can't support that many databases.
So the technology is available, but also a scaling of the people, having the resource from the people is also important to support different purpose-built tools.
Yep.
So it has to become to the equation when you choose databases, because the trade-off will be cost of the people is a cost as well, right?
Yeah.
Like more different skill set and so on. And this is like probably like we in the past we intersection a bit, like there is customers running like analytics on RDS or relational databases, and then or trying to run transactional on Amazon Redshift like data warehouse.
Yeah.
And how like, okay, when running like OLTP engine and say like, actually this is analytics and you'll be better off running in data warehouse like Amazon Redshift, for example.
Yeah.
What do you experience, Kate, on that?
Yeah, I was about to say we haven't really talked about Redshift, like much of the analytics area, but yeah. So I think that is definitely a good one. So I think to explain the main difference, ultimately Redshift is still Postgres. It's just a Postgres, but it's how the data is. I mean, at a basic level, an analytics database, it tends to be I can never say this right, columnar, which means simply how your data is stored on disk. So when you're running in an OLTP system, so like an online transactional database, day-to-day transactional, lots of reads, lots of writes, everything changing loads. Things tend to get grouped in like rows because you would tend to pull a few bits of a row out, or you tend to return like the bulk of a row. So the data is stored. It's really hard without a picture. Sorry, I wasn't expecting to go this deep. So it's the rows tend to be a row, another row, a row, a row, a row, right? Rows one by one. In a columnar database, they're actually ordered by columns. So you'd have column A, column B, column C, and they would all the columns would be lined up together. And the reason why that matters, if you think about how databases still work, and a lot of stuff is stored on physical disks and how they access that data. If you need to get a whole row, you just go to one place on one disk and the whole row is returned. Quick. When you need to if you're doing analytics, so if you think about how online systems work, we're talking maybe an online shop is a really good example. You tend to only be interacting with a small number of rows at any one time. You update a shopping cart, so you put an insert on a shopping cart table. You sell an item, you decrease the number of items in stock by one. Again, single row, single row, single row. But when you're doing analytics, you'll be saying something like, tell me the sum of all batteries that I sold in the last month. Right. So now you're only actually accessing two columns, but all of them, you're accessing how many batteries and timestamp. So you're actually only accessing two of those columns, but all of them. And you might have billions of rows.
Yeah.
So now when you're doing your search, it's only got to go to column item type, search, find batteries, pull them out. And now it's only got to go and find the timestamp data. So that's why it's so much faster, because of how the data retrieval is done on disk. And that's the difference between OLTP and OLAP. Redshift then adds lots of bells and whistles on top about workload management and structure and queries and cache and all that stuff. But fundamentally, the reason why Redshift works differently is because of how the data is stored on disk.
Okay. Oh, we're chatting away halfway through already. Okay, let's get into the demo. What we're going to demo today, Kate? I think
I'm not sure we are going to demo a great deal today. It's not gone great, this demo. So in typical wonderful real life world, I had a lovely demo built on. So on Friday, I spent most of my Friday building a lovely demo that effectively did a benchmarking test with the same data across 5 different database engines. So effectively, we loaded 1 million records of various types, basically producing an order system, 1 million records, custom tables, and we ran the same query, ESC, across all these different engines. That was all brilliant. It proved loads of stuff. It meant it was really quick on Postgres and terrible on everything else, but I had some great demo. Over the weekend, it stopped working. I only found this out a few hours ago. So I don't really have my demo. So I don't have my great one. I will try and do I've got it all in code, but I haven't been able to get it working. So what I'll do, I'll create I'll create a GitHub repo with it on there. If anybody wants to go, I doubt it'll cost you more than a few dollars, like to go. But what I can try to show instead, I'm really worried this isn't going to work now. Let's see if we can get this to work.
So ideally, people can try against different database engine.
That's fine. That's not fine. That's all right. We can go. What is going on now? There you go. The wonderful world of technology. It doesn't want to. There we go. So basically, what I did in the background was, I'm gonna try it a little bit bigger.
Yeah, probably.
Oh, that's gone a bit weird now. How's that? Right. So really, what I want to try to show is if I do a really, really, really simple like PG Bench, basically. So PG Bench is a Postgres benchmarking tool. And how it runs in the background effectively runs a series of transactions. So it's very much an OLTP type transactions. And what I want to basically try and show is one of the biggest problems we have is when you have a huge number of like concurrent connections. So that tends to be one of the biggest problems that you see on relational databases, is when you have just huge numbers of connections coming in. Because all of those are locking, or they're all trying to update. When you do an update or an insert on a table, the rows get locked, which then means that other people can't access them, and everything just starts to snarl. And when you start hitting that problem, chucking more CPU at it or more memory doesn't fix your problem, because if you've got rows that are locked, all that will do, they might be locked for a slightly shorter time if there was more memory or CPU, but really that doesn't fix your problem. When you start ending up with everything starting to fail, that's when you start to, when that number of connections gets maxed and everything starts to fail, that tends to be when it's game over for relational. So what I'm hoping this will show is how quickly this bombs out. But as I say, I haven't got a great deal of faith in this. It's going to run now, isn't it? It's just going to run now.
Live demo.
Yeah, good on live demo. So I'm trying to hit this with 10,000 connections. Okay, let's see if I can at least run my password. There we go. All right. So basically, this is going to try to spin up basically 10,000 simultaneous connect transactions. Transaction does like a select, an insert, I think an insert, an update, delete, and then another select at the end, effectively like a little transaction block. And I'm hoping this will bomb.
Or if it
doesn't, it just shows I'm running this against Aurora serverless.
Okay.
I'm hoping it will bomb, because if it doesn't, it just shows that Aurora is perfect for every use case.
And the code that you will share in the GitHub, everyone can use the code to test like their own databases, different engine. So you help to
I'll get that. I'll get that set up, because don't do this to me. Don't work. I've run this 20 times and it's failed every single time. I actually want it to fail, and it's decided it's not going to fail. Come on. Let's just talk about that doesn't fail in the background, totally proving my use case wrong. Never do live demos. We learned that, Lydia. How many live demos did we do in our time? Pre-record them.
So while we're waiting, there is a comment from Schizophrenic Web Developer. The con of duplicating data is when something changes, you need to update this in multiple places.
Just going to
yes, for this, like I think yes, but can you? Well, this if you completely duplicate, yes, you have to. But like if you have timestamp at the end, you can just assume it's like kind of like a pen-only database. So you just return the latest records. Unless it's a perfect duplicate, I mean, like every value is exactly the same, then you will have to duplicate it. I mean, you have to update in duplicate places. But most of the time with this like duplicate use case, typically this isn't a pen-only situation, right? Like in Dynamo, you pen only the rows, so you only get the latest records for returning for whatever application you have. Okay. While waiting for the demo,
it's just decided that it's either just not running in the background, or it's just not hitting it at all, because it's not doing anything.
And this is if anyone like uses RDS or Aurora, this is the monitoring dashboard that they have to look add, like to understand whether you hit performance issue or not, and whether you should decide whether you move to different databases because you have a lot of connections or not, right?
So this is me running it a little bit earlier. I mean, I also got
Okay.
some stuff from running it earlier. So you can see running it earlier, I hit it with about, and it failed really quickly earlier. It failed after literally in about a minute, by which point it was only using, and this is what matters, it was only using 50% of the available ACUs. So what it's saying is it could have actually scaled more. So the database could have given it more CPU and more memory to do the processing.
Yep.
But that wasn't really the problem. The problem was basically the number of database connections and the connectivity at the time. So you can see, I can try and make this a bit bigger. Oh no, that hasn't worked. A bit. Okay. So the number of database again, I'm only on a so basically the number of database connections only got to 573, not even 1,000, let alone 10,000 before it bombed out. But you can see the CPU utilization was already low, but the commit throughput got up to what, 36 seconds. So that effectively, you can see, so effectively, like your commit latency you basically got, so the commit latency started to rise, which effectively meant that on Aurora it wasn't able to write the data anymore. So this was nothing to do with CPU or memory. Making this instance bigger wouldn't actually have fixed any of the problems that we hit, because all of the issues was around it just couldn't write any faster than what it was already doing, and it was nothing to do with CPU or memory. I'm trying to see what else we can get on this one.
So you, from the user standpoint, you get performance issue, but that is not because your CPU is too small, but it's also could be from the number of connection is a lot higher. You see, like if you just only check the CPU, you still get like that 15%, which is, oh, it's fine, I have enough capacity. But actually, your connection higher, the commit latency is higher, then that also causes performance issue, not just that small
exactly.
CPUs.
Let me just switch back and see if it's broken yet.
No worries.
There we go. Yes, we did. We finally got there. Hold on 1 minute. Okay, we finally got it broken. It's not that interesting to see it break. Oh my word! Every time I do this, it decides it doesn't want to play. Other way. There we go. So this is what you'll start to see. So thank you. This is what you'll start to see. So effectively, basically the connections failed. So there were so many connections hitting the database simultaneously that weren't able to write anything. They weren't able to do what they needed to. So this is obviously like a PG bench error, but it basically said, so it got to, actually only got to 2,000 like connections before this one failed, but it's better than earlier. But you can see then it basically got to like effectively almost the 2,000th connection, and it failed to send like the remaining the remaining slots reserved. So effectively, the good thing that RDS does, which is far better than if you self-manage, is the problem is if you self-manage, you can get a situation where every single connection is full and there are none left.
Okay.
And you actually can't log in as an admin because there aren't any connections at all. And if everything's really snarled up, you can't even log in as an admin. But what RDS does is RDS keeps, so even if you say, I want to allow, basically RDS gets to the point where it holds some connection slots available. So RDS can always get in, and you can always get in as an admin to make sure you can go and then kill all the sessions that are causing you pain. Yeah. So basically this, if you're starting to see like, you're running out of connections and you're starting to see some of the patterns that we saw on like the performance insights, where actually CPU isn't flat, the memory use isn't that bad, but everything's just, you can see that your commit latency is very high, starting to get high. That really starts to indicate, okay, you're starting to hit some of the limits around probably what a relational database can do. And if you go and have a look at things like performance insights, which again, I will attempt to jump across to.
Okay.
Yeah, so if I go into performance insights on database insights, sorry, it's been rebranded, apologies, into database insights, and you go into things like your weight, you'll start to see here lock transaction ID. So particularly in Postgres, so in Postgres, effectively every transaction is given an ID. Yeah. So if you and this is actually part of the reason why it's a good little segue into DSQL. So every transaction is given a transaction ID. And what happens is at the start of that transaction, Postgres effectively takes almost like a snapshot of the data that's required for that transaction. So whilst your transaction's running, you've got consistent data. So if things are changing around you, it doesn't matter because you've kind of got your sort of consistent view of it. But ultimately, And so what it does, effectively, it keeps snapshots of those transactions.
Okay.
And when the transaction finishes, they get released, but they don't get deleted. And they don't get deleted until the vacuum process runs. So anybody who's worked with Postgres will be well aware of like vacuum tuning. Basically, vacuuming is when effectively Postgres says, hey, I don't need these old records of data anymore, these old copies of tuples, they're called, basically old copies of data blocks. I don't need these anymore. I'll mark them. And then the vacuum process comes along and runs and literally hoovers them all up and deletes all the old records. So the reason why DSQL is so clever is DSQL uses that functionality. So because every transaction kind of creates its own mini version of the database of the transaction that it needs at that time, what DSQL does is DSQL, rather than locking it, DSQL doesn't have any locks. So rather than locking it at the database level, what DSQL does is DSQL creates a mini VM, effectively almost like a Lambda function, if you like, a little Lambda function that runs. And that Lambda function uses that transaction ID to pull into memory in Lambda. It's not Lambda, but I'm using that to keep it simple. People can get their head around it. Into this mini VM, effectively holds a copy, if you like, of that data in that mini VM, completely isolated. So now when you run your transaction, you do all your selects, your updates, your modifications, you're not touching the database at all. You are entirely isolated. And it's only when you do your commit at the end of your transaction does everything that you've done get sent back to the database. And that is what allows DSQL to scale at ridiculous levels because it doesn't have locks on the database level. It doesn't have this transaction locks.
For those who are new with DSQL, we launched last reInvent, a preview version. I think it's GA now, if not mistaken.
About a month ago in GA. Yeah.
Right. Amazon Aurora DSQL. In that case, like when you send a commit, if like thousands of applications send a commit, like a hypothetical situation, like all together, DSQL is still able to handle it, or it will call?
Yeah, so it has this idea called optimistic locking. So most databases have pessimistic locking. That means I come along and say, hi, I want to update this row, this row, this row. The database goes, okay, they are yours. And it locks them. And if somebody else came along and said, hey, I want to update here and here, I think, no, you're going to have to wait. She's doing it. She was first. So that's a lock. And that's what you see here. So you see like lock on your tuples, effectively a lock on the tuples here is basically where they're unable to, is effectively a lock on data that's being held. So that can't then, so the lock on data effectively doesn't allow you to modify. That's sort of what that means. And you can see lots of locks going on here all over the place. So that's called pessimistic locking. The first person locks it and no one else can modify it. So then when I commit my data, I know that nothing else can have changed the data that I wanted to change. Because if it's held in my transaction, I've got it until my transaction completes. You can do selects, but you can't modify it. So I know, like, you know, if I add 10% to a column and you come and add 1,000 to that column in the meantime, my plus 10% will be different. Do you see what I mean? Because you've added. So it gets locked so that I know that what I've done is exact and consistent. But because DSQL doesn't do that, you're right. You could have 100,000, probably. I think it's near enough limitless. We tested it. There's a really good blog, which I will try and Google while we're doing it, or maybe Ibrahim can. If you look at Mark Bowes, he's the principal software engineer for Aurora, effectively Aurora DSQL. He's effectively the man who programmed it. And he wrote a really, really interesting blog about how it works and how it scales. And he scaled it up to millions of connections per second nearly, and it still carried on. But the problem is that because the locking is optimistic, because nothing actually gets locked, anybody can be updating those records at any time. So it's very common on DSQL that you will get an awful lot of conflicts, and you have to deal with conflict collision, because when you hit commit, it then goes. So the reason it basically gives everything a timestamp. So when you start your transaction, you get a timestamp, and those are kept. They're very accurate. So it knows what the data looked like at your timestamp based on the transaction ID. You've got your record. It then goes through and looks, has anybody updated this, this, and this since I did mine, since I made my modification, right? If someone else has committed and changed the rows you were going to update since you tried, yours will fail. And that's known as optimistic locking. So talking about different use cases, a lot of people say, okay, we're struggling with consistency, we're struggling with scale, we're struggling to grow. I've already had this conversation with lots of customers. We're struggling to grow. Do you think we should go to DSQL? And I'm like, let's have a look at your code. No. Because if you are running a transaction that's more than super fast transactions, you can instantly see that the longer your transaction tries to run for, the more likely it is that somebody else will have updated the records that you're trying to update yourself. So the longest that DSQL, the longest it's allowed to run for is 5 minutes. If you have a query that runs for more than 5 minutes, it gets killed. But on top of that, if you tried to run a query, imagine an online transactional system. Imagine Amazon.com on Black Friday, right?
Yeah.
Just imagine you have a transaction that runs for 1 second, just 1 second. How many other transactions are likely to have modified the same rows you're trying to within a second? So
yeah,
for a lot of use cases, DSQL won't work. It really is huge scale, exactly the problem that we're talking about. Huge scale, massive concurrency, like massive scale. So thousands, tens of thousands, hundreds of thousands of simultaneous connections, really, really huge volume of queries, but all those queries are small. So a massive shopping cart, a massive online service with lots and lots online scoreboards for a gaming module, something like that. Really, really quick, super fast. Very similar use cases to Dynamo.
Okay. And that would work with Dynamo, likely.
Yeah. Because if you think about how it scales, so Dynamo and DSQL, they scale in a similar way.
Yeah.
That they both effectively spin up more VMs to like handle the data transactions. That's what Dynamo does. When Dynamo gets very busy, effectively splits into a new compute module. Effectively splits them like the compute nodes and keeps splitting until it avoids hotkey. You know, effectively just keeps splitting them until you know, it reaches the demand. And in a way, that's similar to what DSQL does.
Okay. Oh, Ibrahim shares some documentation for if you're not familiar with Aurora DSQL. It shares some links to that. Like we're talking about concurrency control. It's in there as well. And then the block that you've just mentioned, Kate.
Yeah, I'm going to try and find that one really quickly while I'm on here.
Don't worry. If we
I'm only
haven't got
showing
the
it.
link
I'm
now,
only showing it because I get name dropped in it.
we can share it.
It's on our chat, Ibrahim.
Okay. Ibrahim can share it, but also if you after the show we will have the show notes, then you can see all the links that the Ibrahim shared in the chat as well. And then we have 5 minutes left. So like to summarize this thing, if I'm new and then what is the mental model that we have to follow? What is the question that we need to ask ourselves to say like finally comes out to say like, okay, this is a database that I need for now. And in the future, when I hit this, I have to think about the other things.
So you want to define the problem first. So you want to understand what it is. So a good example would be huge scale, so 50 terabytes worth of data that needs to be hosted. And then you want to define things like effectively like, you know, what's actually happening with that data. So is it read heavy? Is it write heavy? Are you looking to do like transactional? Is this quick, simple majority insert updates? Or are there a lot of like, you know, are you very read heavy? Because that also changes basically what you're trying to go for, you know. So let's say you've got like a far larger number of like writes than you do reads, which is, you know, fairly common pattern, but you've also got loads of like performance issues that are coming to intermittent ones. So sometimes it works great, other times it doesn't. Yeah. And it seems to be much slower when there's higher numbers of connections. So you want to really closely define what the problem is. Like it's a bit slow, isn't great. What is it slow at? Is it slow at writes? Is it slow at reads? Yeah. Have you tuned? Have you looked at your index usage? You know, what are you running at right now? You know, have you gone through and gone as far as you can, you know, based on your ability and your knowledge? If the answer is yes, then okay, maybe let's consider something different. So you want to look, then go a bit deeper, look at the access pattern. So, you know, you might have a case where lots of inserts dominate and you've got lots of really complicated where clauses and where filters like within your searching. So that's going to rule out an awful lot of other databases that can't handle complicated filters. So you really want to go through. And then what I recommend is effectively start ruling out. There's too many options on AWS. You can't evaluate everything. So start ruling some things out. So we've talked about you need to be persistent. Well, that's ruling out Elasticache. That's not persistent. It could, you could use MemoryDB. We haven't really talked about these. So these are caching technology. So Elasticache is basically a memory database. So your there are no disks really. Everything's stored in memory. It makes it very fast, but also it isn't. Elasticache isn't persistent, which means the data doesn't get saved. If it fails over or aborts, your data is gone. So it's just cache. Then you've got MemoryDB. MemoryDB is persistent. So MemoryDB writes all of its changes to like a journal. And the journal gets backed up and saved. So MemoryDB is Elasticache with a kind of a semi-permanent backup recovery model that sits on the side that allows you to get your data back if you need. MemoryDB, though, is very expensive for large data sets. It's not designed for you to be running a massive 50 terabyte database. It would be extremely expensive.
So you want to start size matters as well.
Sorry?
Data size is also like matters. Okay.
Yeah, so again, you probably want to write things like Neptune. Graph database doesn't necessarily fit all that well, directly to a relational. Time stream, maybe. If your data's got a very strong time element and is really ingest heavy, then time stream can be. I think time stream is massively underused. Could be a really good fit. But I recommend basically go through and start deleting things because you can't assess everything. Your mind will blow if you try. So delete the ones that really don't fit. And then look at what you're left with. So 9 times out of 10, you'll be left with DynamoDB. You might be left with Keyspaces or DocDB. They're, slightly different. Okay. Maybe not Cassandra. And then it's really about analyzing those different databases. Again, really, really based on those use cases. But the golden rule is start simple. Start working more up. So start with S3. Does that fit? No. Okay. Maybe RDS and Aurora. Okay. Does that, or Dynamo? I would actually put those next to each other depending on your use case, and then go more specific. Time stream, DocDB, MemoryDB. Then start getting more specific as if it doesn't meet your needs.
So if your use case still like generic, or you don't have like very specific use case, you can still start with the relational database like RDS or Aurora, and then when we can put specific look into like those watch out that you share, like if you got performance issue, is it actually you need more CPU, or CPU is fine but like there's something else that's wrong, and then you start like rolling out, okay, I still need persistent databases, so anything in memory doesn't fit to my use case, so leave it out and continue like to see like which database will be fit into my use case.
Yeah but I think actually if I was to design a new application from scratch today, and I didn't have any pre-existing code and I could totally define what I wanted it to be, I would probably start with Dynamo. Even though in my background, I actually think Dynamo would be where I would start my investigation these days. I don't think I'd start any more on Aurora.
Relational.
I think I'd start on Dynamo. Yeah. I start on Dynamo, and then if I really did need relational, then I could move across. But I think that I would start with Dynamo these days.
Okay, interesting. And then Ibrahim share all the links. Of course, it will be in the show notes as well. I think we just got on top of the hour. Please, thank you very much, Kate, to summarize everything. Everyone who just watched it late, we will be on-demand version will be available in the show notes. You can watch it again for you to help decide what database you use or evaluate whether this database is still fit for your purpose and so on. And next week we have Ibrahim. Actually, it's going to be in the host seat, and then we'll talking about solving multi-tenancy issue with in Aurora MySQL using AIML. And the guest will be Ranjini, one of specialists, and also she's built an AIML solution to understand like multi-tenancy issue within Aurora MySQL. Thanks all for joining us today. Thank you, Kate, for your time. Well, I think we need to have more show with you to talk about more specific databases. Again, thank you, everyone. Take care. Have a good day. Thank you. Bye-bye.